Okay, from the part 1 of the video, we had an example in which our A was 5, our AR or second term was 10, our AR square or third term was 20. Now there is one thing in geometric progression: if you divide the second term by first term, you get common ratio. If you divide the third term by second term, you get the common ratio. And we also discussed in previous two videos that S or sum of sum to infinity of a geometric progression is A divided by 1 minus R. This was derived in the previous videos. So we will need knowledge of both these rules. Second divided by first term is R. Third divided by second term is R. And in sum to infinity we discussed that R should be less than 1. Okay. Now let us merge both the concepts. Look at over here. Our dividend valuation model said just sum up all these terms and you will get the shares price. Let's say this is A. Let's say this is A. And if it is a geometric progression, it is a geometric progression, but if you want to prove it, if you have to prove any geometric progression, you simply divide third by second term and check if it is equivalent to second term divided by first term. If this rule is being followed, the series is geometric. So let us first check whether the dividend growth or whatever the present values we have to calculate, all these are actually whether they are in a dividend valuation model, are they in a geometric progression or not. Let's say this is our first term and this is our second term, and therefore this is our third term. Let's say we first calculate second term divided by first term. Second term is d0 1 plus g square divided by 1 plus divided by k 1 plus ke, okay, 1 plus ke square divided by second term divided by first term. Our first term is d0 1 plus g divided by 1 plus ke, and I can solve it as it will be d0 1 plus g square over k 1 plus ke square, divide into multiply, and therefore 1 plus ke divided by d0 1 plus g. This and this will cancel out, 1 plus g will cancel out with this square, and this square can cancel out with this. So our r is our value of r is 1 plus g divided by 1 plus ke. What we did is that we divided the second term by first term and it gives us an r of 1 plus g divided by 1 plus ke. If the third term divided by second term gives us the same result, the progression is actually a geometric progression. Let us check it for the third term, which is d0 1 plus g cube divided by 1 plus ke cube divided by second term, which is d0 1 plus g square divided by 1 plus ke square. It will be d0 1 plus g cube divided by 1 plus ke cube multiplied by 1 plus ke square divided by d0 1 plus g square. This d0 and this d0 will cancel out, this cube and this square will cancel out, this square and this cube will cancel out, and again we will have 1 plus g divided by 1 plus ke. So we have firstly confirmed that since second divided by first term and third divided by second term are equivalent to each other, this progression is a geometric progression, and our value of r is 1 plus g divided by 1 plus ke. We further know that sum to infinity of a geometric progression is a divided by 1 minus r, and we further know that r should be less than 1 if you wish to apply this model. we know this information. We have derived each and everything in previous 2 to 3 videos, and we know this information till yet. Yes, we further know the value of a. A is always the first term, and this is our first term. So our first term, or a, is d0 1 plus g divided by 1 plus ke. Here we go. Things are really clear now. And if I have to apply this formula, one thing to remember it is that r should be less than 1, and I can only apply this formula if r is less than 1. And therefore, if you check this, let's say if your growth rate is 5% and if your ke is 10%, your r will be 1 plus 5% divided by 1 plus 10%, which comes out to be 1.05 divided by 1.1, which is 0.95. I can apply this formula if growth rate is less than cost of equity. But what if my growth rate is 10% and my ke is 5%? R will be 1 plus 10% divided by 1 plus 5%, and the value will be 1.1 divided by 1.05, which is 1.04. There can be no sum if r is greater than 1. Remember, we discussed in the second part of this 3-part video lecture that if r is greater than 1, you cannot calculate sum to infinity. Obviously, the dividends will keep on growing and the company will keep on receiving increasing sums. Please check second part of this 3-part video series. So point to note is that dividend valuation model is only applicable if the rate of growth is less than ke, because if growth is greater than ke, there can be no sum to infinity. And if it can be applied in this model, how do we actually apply it? We use the sum to infinity of a geometric progression, which is s is equals to a divided by 1 minus r. And since s is equals to a divided by 1 minus r, if I put my value of a, my a is d0 1 plus g divided by 1 plus ke divided by 1 minus r. 1 minus r, my r is 1 plus g, 1 plus g divided by 1 plus ke. Solving it, it will be d0 1 plus g divided by 1 plus ke. Divide if we turn it into a multiply. Let us leave it like this. Let's first take LCM. If you take LCM, 1 plus ke, 1 plus ke minus 1 plus g, and now if I solve it, d0 1 plus g divided by 1 plus ke divided by 1 plus ke minus 1 plus g will be ke minus g divided by 1 plus ke. Further on, d0 1 plus g divided by 1 plus ke multiplied by 1 plus ke divided by ke minus g. These two will cancel out each other and we will be left with finally d0 1 plus g divided by ke minus g. Thank you all for watching the video. Thank you very much.